All right, so we've got logarithms. I'm talking about the properties of logs. They're very similar to exponents. And we're just going to go through and do sample problems to like define what the rules are for logs. Remember, they're same as exponents. Here we go. Let's do product first. M times N. When you're multiplying logarithms, you're really going to add. So write the word add. I separate it into two separate. So I keep the word log, I keep the base. I'm going to add M plus, and then I write the word log, keep the base, and N. So an addition is the same as a multiplication. Here's an example where I have to make it into multiply. You keep the base 5, but you're just doing 6 times 7. So a plus sign means make it into multiplication. Log base 5 of 42. We're starting. Can you? All right. Expanding means make this into an addition problem. What two numbers make 63? You guys, what makes 63? 7 times 9. So I'm going to make it into an addition problem. Separate it. Make it 7 plus log base 2 of 9. So I make it into an addition problem. I'm kind of doing opposite things here. If I see an addition, make it into multiply. If I see a number, I could break it down into an addition problem. So you need to know your times tables for these. Product rule means you add. Quotient rule, subtract. Okay, here we go. Log base b of m, and I'm going to subtract minus, and I keep it, oh, it's not 5, I'm sorry. It's just base b. That was the last problem. So m minus n. M minus n. Fraction means subtract. All right, here's subtract. Change it into a fraction. Log base 4 and do numerator, denominator. 84 over 12. It does go in evenly. I've got 12, 24, 36, 48, 60, 72, 84. So it goes in 7 times. If I can simplify it, I do. Log base 4, and the answer is going to be 7. Okay. I see this 9, and I want to make it into a multiplication. What multiplies to make 9? Okay. Oh, but sorry, this is division. I'm sorry. What divides to make 9? 18 and 2. What else? Ay, ay, ay. 9 and 1. Any one of these combinations is fine. Let's pick the easiest one, 9 and 1. What base is this? Because I don't see a base written. 10. When nothing's there, it's a 10. Here we go. Log base 9, fraction bar, log of 1. 9 over 1. Okay, power rule. The exponent moves behind. And here's what I mean. The n would go in front, and I'm reversing it, or in front, wherever it's located, okay? So that n, this is new, you haven't seen this before. The exponent moves to the front. It depends on what order you're going in, right? So I'm going to make this, the n moves to the front, n times log base b of m. Okay. Where's the 2 going to go here? Where do I put the 2 then? If it's already in front, where does it go? In the back to the exponent spot. Log base 3 of 8 squared. You can do 8 squared. Log base 3 of 64. Okay, reversing it. Where does x minus 1 go? In front. X minus 1 times log base 2 of 6. And you just leave it like that.
Big fan of like product rule. Why can't you add like the 7 and the 9 together?
Because plus means multiply. So it would never be 16.
So you can't like multiply?
No, because it means 63. Multiply. I multiply them. I'm not adding them. All right, let's talk about the top. Never did this yet. Match. What if the base is the same as the number? This is going to equal a 1. Matching. They're the same number, make it a 1. Okay, that's just a rule. Here, example 1. They're both 14s. The base is 14 and the number I'm trying to find the log of. The answer is just 1. Second rule. The base of any base of 1 gets you a 0. Log base 20 of 1, 0. Log base 6 of 1, 0. Log base 10 of 1, 0. Log base 3 of 1, 0. Okay? We're going to talk about change of base tomorrow, but at least I'll introduce it. All right, here we go. The bigger number goes in the numerator. The little base goes down, drops down to the denominator. This is called change of base. This is when the bases are different. And I want to try and make them the same. They both become base 10. They become base 10. So I'm going to go log of A, which is base 10, divided by denominator log of B. 32 over 7. Let's try it. Ready? It becomes now no longer base 7. It becomes just log 32, which is a base 10. Then the 7 goes on the bottom. 7 on the bottom. Okay. So now we're going to use this. I kind of put the homework on the wrong spot. This is where notes starts. We're only doing condensing today. 1, 2, 3, 7, 8, 9, 13, 14, 15. That's all we're doing today. And it's too small. Let me zoom in. Sorry. Okay. Remind you of the rules. Here it is. Product. You add. Log base b of m plus log base b of n. Add. All right. Condensing. It's already a plus. What do I make it? If I see a plus, what does that mean? We'll just have silence on the video. That's fine.
28.
Plus sign. Yeah, you multiplied them. Good. Log base 2 of 7 times 4. Log base 2 of 28. Okay. This is a plus sign, sorry. Plus 25 and 4. What do I do to those numbers? The whole class needs to know what to do. What do I do with the 25 and a 4? Multiply them. Thank you. 25 times 4. Log 100. Okay. 2x and 4x squared. Multiply them. 2x times 4x squared. But 2 times 4 is 2 times 4 is 8. X1 times x squared is x1, x squared, x third. That's your final answer. Log base 4 of 8x to the third. All right, quotient. Subtraction means fraction. Subtraction means fraction. Okay, I've got numerator, log base 3 of 24 over 8. You don't even need to write log twice. You can just write it one time. Log base 3 of 3. Okay, match, match. What happens when I match, match? 1. Just a 1, guys. I'm not even going to write the word log anymore. Huh? Okay. Because these match, so it becomes a 1. I don't have to write log anymore. Nope. 15 minus fraction. 15 over 15. It becomes 1. Log base anything of 1. Base whatever, but there's a 1 there. So large number's a 1. 0. Okay. Write a fraction, please. Log base 4. And you'll write a fraction. x9 over x squared. Yeah, you simplified. 9 over 2 is 7. Log base 4, and it would be x to the 7th. Oh, you can't see. Sorry. All right, 3. Division, subtraction. Last, the exponent moves. So this 5 is in front. Where do I put the 5 now? To the back. 2 to the 5th. Miss Hill. Hi. Where do I put this 7? Log base 2, x to the 7th. So if it's in front, it moves. Where do I put the 1/3? Oh, you know what? 8 has a cube root. Because isn't 1/3 power the same as the cube root of 8? What is 8 to the 1/3 power? Cube root of 8. What times what makes 8? So you just put, it's still a base 10, but the 8 and 1/3 reduces. So these are just the basics, right? I'm going to now put these together, and you have to do a combo. So turn to the back. We're not doing all these. Putting it together, okay? So let's be careful. Here's what I got. I got an exponent because the 2's in front, and I have a subtraction, which means divide, a fraction, right? Okay. First, do the exponent. Log 6 squared minus log of 9. becomes 6 squared, which is like 36. Okay. But it's a subtraction. What's subtraction? What do I change it to? Subtraction becomes what? A fraction. And let's make 6 squared 36. Here we go. Log of 36 over 9. You don't need to write log twice. Please reduce 36 over 9. Log 4. Okay, so let's analyze what we have before we start. Like this 4 is going to go to the A. This 2 is going to go to the B, right? So I have exponents, and then I have an add, which is going to be multiplied. Here's what you got. Log base 4, A to the 4th, and multiply it, because the plus sign means multiply, B squared. A to the 4th, B squared. We're done with that one. Can't do anything more. Okay, look, the 7 goes with the U. The 3 goes with the V squared. V squared times 3 becomes V to the 6th. So, subtraction means fraction, right? Divide. So here's what I got. I got an exponent, U to the 7th, V to the 6th, and then I have to put it in fraction form. So it's like a little combo again. Log base 4. Ready? On top, U to the 7th. On bottom, V to the 6th. And you're done. Okay. 15 plus 4. This is going to become a multiply first, and then you're going to make a fraction out of it because subtract. So go slow. Plus sign first. Multiply those two. 15 times 4. Log base 2 of 15 times 4. That's 15, 30, 45, 60. Log base 2 of 60, and then make it a fraction over 6.
Can you not reduce any further?
Yeah, you can. I just want to give people time. You reduce when you can. You can do 60 over 6. Log base 2 of 10. Okay. Last two. I got a plus sign and another plus sign. I'm multiplying all of this, guys. Okay, the 4 is going to get multiplied by the y. Oh, what's 49 to the 1/2 power? It can be reduced. 49 to the 1/2 power is what? 7. Because it's the square root of 49. So this is going to become all multiplying. 4 times y times 7. 3 things now. The 4 and the y and the 7. 28y. Log base 3, 28y. Yeah. Oh, because the 1/2 moved to the, it was an exponent, it moved to the 49. So it became 49 to the 1/2 power. And then we've already learned how to change this. So like this, the 2 becomes the square root of 49. Last one. Okay. The 1/3 power of 8 and the 1/3 power of 27. You guys, you know that 8 to the 1/3 reduces and 27 to the 1/3 reduces, right? So here's what I'm going to do. First, I'm going to multiply. I don't want to multiply 8 times 27. No. I'm going to make 8 to the 1/3 of 2 and 27 to the 1/3 of 3. And I'm going to multiply just 2 times 3. Because this was going to be to the 1/3, to the 1/3. Log base 5 of 2 times 3. Log base 5 of 6. Okay. So that was me putting to the 1/3, 8 to the 1/3, and 27 to the 1/3. Okay, what do I do with this subtract? What does this subtract mean? What? Divide. Okay. So please put it over 3. Log base 5 of 2. 6 over 3 becomes 2. Okay. So you're looking, if you see a plus sign, you multiply. If you see a subtraction sign, you make a fraction division. You have an exponent. It can be in the front. Your homework is these right here. Wait. Yeah. Oh, 1 through 8, right? 1 through 8. I'm going to stop